Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Um, I want to start a course of Algebra 1. I already posted some Regents exam solutions, but I want to take it from the beginning so that if you are starting a new year, hopefully in September, you may find it, helpful for you. So today I'm not going to talk much about Algebra 1, but I want to introduce the basic vocab that we will be using, okay? And before even doing that, let's talk about uh, a game, okay? Suppose I tell you, I'm thinking of a number that when I multiply it, let's say by 3, and then adding 5 to that, uh, I will get something like, I don't know, let's make number that makes sense. So 83, okay? So I have a number in my head. I multiplied it by 3, and then I added 5. I got 83. What was the number I was thinking about? Without algebra, and if I don't end up with 83, but I end up with like a 3-digit number, it would be almost impossible to guess this number. I mean, you cannot just say, okay, is it a 5? No, it doesn't work. So is it a 6? I don't know. No, it doesn't work. So you keep guessing and do what we call trial and error until you stumble over the number I pick. And as I said, if the number I picked originally was large, it would be like a waste of time. You will probably give up and hate math altogether, right? So algebra comes to the rescue. And how is that? We know the numbers we talk about, like 1, 2, 3, or negatives or whatever. These are constants, meaning if I come tomorrow, I will find the 3 is still a 3. I mean, it will never change. But what if a number changes? And the idea might be a little weird to you. We say we have something we call a variable that can take on any value depending on the problem. So, and usually we use the letter X, and Y and Z usually for variables, because other letters, usually in math, every letter pretty much has a use in some area of math that you will learn later. But for now, we say, let's concentrate on X, Y, and Z. So when I don't know what you thought of, what number you thought of, I would say, let X be the number or the number you thought of. You have to be very explicit when you write the definition of so we call X a variable because it could be 1, it could be 100, it could be -50, it could be 3.5. I don't know. So because I don't know, we call it a variable. It can take any value. It's like a box that I can put inside any number. But for this specific problem, there is only one number that can fit in that box and make sense. So let's now learn how to translate. I told you, I think before, that when kids ask me, because I'm from Egypt, so my mother tongue is Arabic, and they ask me, so how many languages do you speak? And I said, I speak 4 languages. Say, wow, what are they? So I say Arabic because that's where I born in Egypt, and I speak Arabic. French because I went to a French school, so we learned French from elementary school, from first grade. English because we also learned that in 4th grade, and then I came to the States and I've been living here for over 30 years. And then math. And they say, what? I say, yeah, math is a language. And I love it. So our goal in algebra, the most important goal, is to be able to translate from English to math. So in order to do that, you need to learn the vocab of math, right? So here I call x a variable. And now when I say I had a number in my head, when I multiplied it by 3, well, if I multiplied 5 by 3, I know you say 15. I don't want the answer. I say, how can you multiply 5 by 3? You say 3 times 5, right? If you multiply, if my number is x, it's going to be 3 times x. Common sense, right? So that's an easy translation. The only problem that may throw some of you off in the beginning is we don't try 3 times x. We write 3x. And some people would say, why? Well, the multiplication sign is the only one we don't use in algebra. Not we don't ever use, but we don't use in many situations. And the reason may be easy to explain, because if I write 3 times x, somebody would read it 3xx. What does that even mean? Is it 3 times times? It doesn't make sense. So to reduce confusion, we just skip it. Some people even can use a dot, but the dot is also a decimal point, so it may be another source of confusion. So when I say 3x, it means 3 times x. That's the first thing we do. So we show us as like, well-versed mathematicians. We know how that we don't try 3xx, right? It's just 3x. Also, we don't try 1x, even though many teachers allow that. Well, yes, you can write it, but when I see you write 1x, I say, oh, this guy is not like well-versed in math. He's probably a novice, right? So no, we just say x. Because you can say, for example, I bought a banana, or I bought 1 banana, but why do you say 1? If you say a banana, we will understand it's only 1. So usually we write this and this. We don't write 3 times x, no, or we don't say 1x, no. There are a few minor things also. When I say x, I mean x raised to the first power. And we don't write 1 here. So we don't write 1 before the x, and we don't write 1 as a power, x raised to the power of 1, because any number raised to the power of 1 is itself, right? It doesn't make any sense to write the 1. Also, the square root, I write it square root of x. And here there is a hidden 2. It's a square root. So this is x squared. So square root, I should write a 2 here, right? It's the opposite of the square, but we don't write it. Why? I don't know why. But that's how we do it. We don't write this, even though it's not wrong, by the way. I can add it 2, but I will be confusing some of you. I don't write the 1 on top of the x. I'd simply write x. So these are few things that we will be using in algebra. We'll say x, we'll say square root of x, we'll say 3x, and so on and so forth. So let's go back to our problem. Remember, the problem said, I'm thinking of a number, so I call that x. When I multiply it by 3, it becomes 3x, which is 3 times x. And then I added 5 to that. Added meaning plus. So added 5. I got, meaning equal, I got 83. So now, even though I don't know x, it's easy to find it. Why? Because I want to separate x by itself. I cannot, because it has a number attached to it, multiplied by it. So I say, oh, but I have 5 on the left-hand side. And I told you the equal sign, meaning I have a balance. I have on the right-hand side 83. I have on the left-hand side 3x plus 5, and they are the same weight. So that's why I have equal. The equal sign meaning they are the same. But I don't want the 5 to be here. I just want 3x, and then I will have to have x. So I have two operations to do. And you say, oh, it's easy. Just subtract x. I'm sorry, subtract 5. Yes, I will do subtract 5. But if I subtract 5, this side would be heavier. So in order to return it back to be in balance, I have to subtract 5 from both sides, right? Again, you can think of it as the subtraction is the opposite of addition. And since 5 are added and I don't want it, then I would apply the opposite operation of plus, which is minus. And as I said, because I applied it to the left, I have to apply it to the right. So now my left-hand side becomes 3x, and my right-hand side, you just subtract 5 from 83, you get 78. Now, the 3 is multiplied by x. Remember, we don't try the multiplication sign. But when I don't see anything between the number and the variable, the constant and the variable, it means they are multiplied. And the opposite of multiplication, as you all know, is division. So I'm going to divide the left-hand side by 3. Now I no longer have equality. One side is heavier. If x is positive, then the right-hand side would be heavier. And if the left is negative, it's the other way around. It's still, I think it's heavier on both. So I'm going to divide 3 on the left, and I have to divide 3 on the right so that I still have a balance. The 3 and the 3 cancel. I use my calculator. 78 divided by 3 is 26. So the number I thought of was 26. How can we guess that without algebra? So algebra now is helping me do some games. I can tell someone, select a number in your head and do some operations, and then in the end, I will tell them what they selected. And I look like a magician, even though I didn't do anything other than simple algebra. Okay, so that's why we use algebra. To begin with, of course, I can use it in many diverse situations, and in very complicated cases, I can use algebra to help me solve and find out stuff without algebra would have been almost impossible to know. So now let's continue with some more terms, and then I'm going to leave you here, and that's enough as an introduction. We are going to take it step by step until we finish all the lessons. We end up with a solid foundation of algebra that would allow you to master your Regents exam and be ready to build on that in Algebra 2 and then pre-calc and calc and other mathematical courses, not engineering. Well, in engineering, you have to learn this material anyway. Okay, so let me show you here some stuff. I'm going to say, for example, I'm going to write something 4x squared minus 3x plus 6, and it looks so complicated. There are some terms I want you to learn here because that is our vocab that will build. We want to build our vocab so we can speak math. So what we are going to do is to give a name to each part of that. By the way, we call this whole thing expression. It's not an equation. Unfortunately, even in college, when we use, say, I was an engineering professor. So when I ask a student to write an equation about something and they write 4x squared minus 3x plus 6, I feel bad because that's not an equation. An equation has to have an equal sign. This one, where is the equal sign? Equals what? So that is not an equation. We call it an expression. I'm expressing something. I'm expressing here, the left-hand side, I'm expressing that if I, for example, I have a number, I multiplied it by 3, and then I added 5. And then I'm going to ask, so what did you get? I got 83. Now it became an equation. But the left-hand side is just an expression. I'm expressing what I did. I multiplied it by 3, then got 5. Use my calculator and see, and then added 5. And then I get my calculator and see, oh, this is the number I multiply. What did I get? That's an equation. Equal equation, right? This thing has 3 different parts. We use the plus and minus to break down that expression. Okay, I don't use multiplication and division to break it. No, I break it by addition and subtraction. And notice the first thing we got rid of here was the addition of 5. And then we move to the multiplication or division. So each one of those is a term. In fact, later we are going to refer to these because they are 3 as a trinomial expression. This is what we call a polynomial. And we learn about that later. We don't care about it now. So here I have 3 terms. I have, of course, addition and subtraction, which are operators. So plus, minus, times, by, divided by. These are mathematical operators, and there are other operators we will learn about. Okay? So that's a term, a second term, a third term. The third term here is a constant term. It's constant because it doesn't have a variable. It doesn't have X or Y or A or M. It's just a number. And this number never changes, right? Whether the X is 10 or -5 or 1.5, this is always 6. These will change every time I change X. So they are variable, right? They vary. But the 6, how can the 6? Yeah, 6, 7, I know. Get out of here. All righty. I have a hidden multiplication sign between the 4 and the X square. I have a hidden multiplication sign between the 3 and the X, right? We know that. We said multiplication usually is hidden. So what is the 4? Anything that you multiply as a number being multiplied, not added or subtracting, like the 4 and the 3, these are called coefficients. The 2 and the hidden 1 here, that is called a power. X to the power of 1 is X. X to the power of 2, we call it X squared. X to the power of 3, we call it X cubed, and so on and so forth. The 2 here is the highest power in that polynomial, highest power, and we call it the degree. So the degree of this expression is 2, because 2 is the highest power. Okay? The X, as we said, is a variable. The 6 is a constant. These are coefficients. These are 3 terms. And I don't know if we need to add something else. We call, if it's an equation, so this is an equation. And because it's an equation, I can solve it. But if I tell you solve this, it doesn't make any sense. What do you mean solve? What do I solve for? I don't know what this expression is equal to. To what? If I know, then I will be able to solve it. But if I don't know what this expression is equal to, what does it mean to solve? Okay, how do I solve for x if I don't know what this whole thing is equal to? Like you tell me, oh, I thought of a number, I multiplied it by 3, and then I added 5. What is the number I thought of? It could have been anything. How do I know? You have to give me an extra piece of information. You say, oh, I got that. I got 98. Oh, now we are talking. Now I can solve. And if it's 98, it means you picked 31. But without telling me what you got, there is no, unless I'm a wizard, I wouldn't be able to read your mind and find out that. Okay, so basically we are using algebra to help us solve problems that otherwise would have been so complicated and so hard to solve. And I think I just wanted to give you an intro to these terms that we will be using extensively. So there is no reason that every time I say, oh, by the way, I said coefficient, and coefficient means it's a multiplier of a variable, whether the variable is x or x squared or square root of x or sine x or whatever it is, that is called the coefficient. Oh, and finally, the coefficient, maybe I will throw this in, coefficient of the highest power, which is the 4 in this case, it's the 4, is called the leading coefficient. If I have a polynomial meaning I have an equation or an expression that has x squared, x cubed, x to the 4th, so it's always a positive integer power of x to the 1st, x to the 2nd, x to the 10th. We said the highest power is called the degree. So in this case, the degree is 2. The coefficient of the highest power, which is x squared, is 4. So it's called the leading coefficient. And sometimes we are going to simplify that by saying LC. The LC of that expression is 4. Okay, I think that is enough for now to absorb. And then we are going to start actually, this is an intro. So the first lesson, we'll start it Monday, since today is Friday. Thank you for your time and for watching, and hope to see you soon. Have a great day. Bye.